Okay, hi everybody, thanks for coming. I should preface this by saying this is not a wiki-specific activity. I want to tell you about something cool that I think you can do in your classes and that is specifically really helpful for IBL classes, but you do not have to know about wikis to do it. So if you have technical questions about wikis, happy to talk about it, but maybe not during the talk window time. But here's an outline. What I'm going to talk about is the motivation and context of this activity that I created for my class. We'll talk about, it's called WikiLogs. So I'll talk about the assignment. I'll talk about why I perceive this as a success, and then some keys to that success, or why I think it actually worked. Oops. Okay, so the context was an honors section of vector calculus. I had 17 students. Most of them were freshman STEM majors. The whole course was framed as the evolution of calculus. So we were looking at vector calculus as coming from single variable calculus, and it was really about students tinkering with ideas and working example problems and then making generalizations. So the whole course was framed this way. But the students had to do pre-work before class each day. I needed them to be prepared for discussion, so I assigned a certain number of problems. They were required to have those ready, and usually the pre-work would constitute about 70% of our, or 75% of our class time. And so I introduced this assignment, and the crux of it is that I had the students submitting their pre-work results online. And my primary motivation was I wanted to see what the students were thinking about the pre-work before I started planning the day. So I could orchestrate better class discussion. So my students are working in groups, they're presenting things, they're doing all kinds of things, and I wanted more information before I set them off to do their thing. So I want to talk a little bit about wikis, and like I said, I wanted a way for them to submit the results of their pre-work online so I could check it about an hour before class, and I chose to use a wiki because it's something I'm familiar with. And a wiki, for those of the uninitiated, is a website developed collaboratively by a community of users, and any user can add and edit to the site. The browsing is just like a standard website, and the editing is WYSIWYG. What you see is what you get, so it's like typing a Gmail. Moodle is the course management site we use at UCSB, and it has its own built-in wiki. I think Blackboard also has a built-in wiki. One nice thing about the wiki in Moodle is that it allows you to use LaTeX, so my students could type up in LaTeX. And in the case of the WikiLogs, and this is why I'm saying it's not a wiki-specific assignment, the community of users was just me and one student. So we were the only two people who could see what the student was posting, and I called it a personal wiki. The class as a whole had a class wiki that everyone could see and was posting on, but that's a separate sort of assignment. All their pre-work and posting those results was on the personal wiki. So it's a lot like what Patrick was talking about. It's just two of us can see what's going on there. So the standing assignment was students were expected to post their progress on the pre-work problems before each class. And so more specifically, I told them to complete their pre-work problems in the notebook and then just report the following. So there's 3 bulleted things. The answers if they get them, and I made a distinction between answers and solutions. So I wasn't looking for a whole solution, I'm just looking to see if they got the answer and what answer they got. If you can't finish a particular problem, then you have to come up with a question. And even if you do finish the problem, make an observation beyond the solution or ask a question that the problem brought to mind. So for each pre-work problem, they had to do this extra step. Again, this is what the page looked like to the student. And that, again, each student's WikiLog had the same front page, and the instructions were right there every time they went in. And so each day before class, they would go in and create a new page for the day, and then on that page, they would post the results of their pre-work. And so I'm making 2 claims today. The first was the thing that I knew would happen. The WikiLogs helped me run a tighter class. I had more information, so I knew what to do with them. But also what surprised me with the WikiLogs sort of helped my students grow as mathematicians. It helped them start thinking like mathematicians. And so I want to talk about that too. So the first benefit was that they helped me run tighter class. The students doing notebook checks this way, so I always had my students do pre-work, and I had been checking it in all my classes. But now checking it online before class was actually more efficient and more effective. More efficient because it took less time out of class. It took no time out of class. But also more effective because students actually told me that they felt like the grades were more appropriate. I would give them a score, check, check plus, check minus, based on effort. Not correctness, but effort. And they felt like the score they were getting for the WikiLog was better or more accurate than the score they were getting when I was just looking at their work in their notebook. And I think that was happening because it was hard to find what they were doing when I was looking at Scratch work. But if I could see them posting reflections on the problem and the answer, then I could sort of more easily evaluate whether or not they were doing the right things. But also, second benefit was just reducing the fear of this sort of losing control in an IBL classroom. I mean, I just felt better walking in because I was like, I've got a plan. I know what I'm going to do with them because I've got this information, I've developed a plan, and I know what's going to happen. Also, and part of that was getting the right students working on the right problems. So students would be presenting problems, working on these problems. I divvied it up usually, and I would have them working in groups on a problem for a few minutes to prepare to present. I could make sure that the kid that made the mistake, that 2/3 of the class was, one of those kids was definitely in the group thinking about that mistake and bringing it to light. I can make sure that the super thorough student who caught every detail was with the student who was a little bit flip about everything. I could pair them in the right way, and then knowing how they had done on those pre-work problems helped me pair them in even better ways. And then I even had my students telling me that they liked, you know, when I was making informed decisions about who worked with who, that it was coming out better. And then the big thing for me was that I could draw out their ideas. I was amazed at the kinds of observations and thoughts they were having on these WikiLogs. I would have never known. And I knew it was out there, so I knew I could say, Timmy, what do you think about this solution? Because I knew he had said something interesting in his WikiLog that would be worth saying in class. And that was really the best. That was fantastic. But even beyond the benefits of running a tighter class, I got to see them start to think and work like mathematicians. I saw them thinking about definitions, connecting ideas and concepts, asking questions about the problem at hand, and generalizing examples. And so I have examples of some things that my students posted in the WikiLogs, but I guess we forget that a lot of the mathematics happens when we're not looking, and I feel like I got to spy on them a little bit and control what they were doing. Well, not control, inform what they were doing in those the parts of the work where I'm not actively present. So some of my students questioned definitions, like a good mathematician should. So this student, we just introduced gradient, and he says, can we just say that the derivative of a function in two variables is the sum of the partial derivatives of that function? And you know, I just replied, the blue is my reply. So I would respond in blue type so they could see really quickly what I was saying. And I said, we got to be more careful. There's more directions in multiple variable calculus. Students were connecting concepts. So this student, and again, they knew they had to post an observation, so a lot of times they would identify it as their observation. So his observation was, the gradient is kind of like a velocity vector. A velocity vector tells you the slope of a tangent line. The gradient tells you the slope of the tangent plane. So I just said, good observation. And then I suggested the wiki notebook was our class wiki. So again, when they made good observations, you should probably put that in the wiki notebook. They were asking deeper questions. So for this particular pre-work, I gave them a bunch of vector fields. They had to compute the curl and the divergence. And one of them had 0 curl, 0 divergence. And this student asked, do a specific type of vector fields always give divergence of 0 and curl of 0? Does this mean something special? I mean, this is like Hodge decomposition theorem type work. I mean, we're going to get into really deep questions about the domain of the vector field and what the consequences are. So it's a big deal if a vector field has curl 0 and, well, that's a big deal question. But also my students started to generalize like mathematicians do. So this junk at the top is them working through the chain rule, like bit by bit, using the one variable chain rule to build the multivariable chain rule. But the important thing is they had not been they'd only seen the definition of gradient. We hadn't talked much about the consequences of that definition or what a gradient vector field really is. But just from tinkering with the chain rule, the student makes the observation, is the gradient vector always perpendicular to a contour line on the surface? Because he saw from building the chain rule that the tangent vector is level. And I said, yes, good observation. I would never have known. This particular student is super quiet. So much is going on in his head that I didn't know about until we started doing WikiLogs. And this was great. I had them finding a parameterization of an ellipsoid. So you take a parameterization of the sphere and you got to stretch the different directions. And so this student writes, this is a simple problem, and we could have done it easily by noticing that x equals a, or basically stretching in each direction and so on. But it is the structure which is important. Linearly transforming a given coordinate system by another. Through this process of defining coordinates by a linear combination, it allows us to overcome a lot of difficulties. So he identified that it was a linear transformation that was getting us the ellipsoid, and he found the matrix for it. That was very cool. I was excited. And again, for these examples that I showed you, there were tons more. I mean, I didn't even have to fish very hard to find this stuff. Because it worked. It was really exciting. But the WikiLog, I think the key to the success was that the WikiLog assignment explicitly shifted the conversation from being right or wrong to exploring the idea and generalizing the processes and sort of dealing with bigger ideas at hand. It wasn't about getting a solution to this problem. It's about how does this problem fit into the bigger plan. But sort of the subtle keys to the success, I think part of it was there was no fear at all of public embarrassment. It was a private conversation between me and the student. Because I noticed a lot of them would be very vocal and say a lot of interesting things in the WikiLog, but then the public wiki, they were much shyer. And I'd have to say, look, you write great things in the WikiLog. I need you to put that in the class wiki. Oops. But also the whole class itself, like this didn't happen in a vacuum. The whole class was an exploration of calculus, this evolution of calculus project. So every day we were talking about how do we take this individual problem and say something bigger about it. And also the students had explicit instructions for what to do when they were stuck. The assignment was very clear. If you're stuck, you've got to come up with a question. If you are not stuck, you've got to come up with an observation. I mean, I wrote notes for this class, and each problem was in there for a reason. They needed to think about what's the reason, what's the purpose of this problem. And also what helped was there was quick and encouraging feedback. If they did something exciting, I put exclamation points on it. I said, put it in the Wiki notebook. This is great. And they were getting the feedback every day, so they knew that I was looking at that thing before class every single day. They knew that it made a difference about where they were going to be in class and what they were going to be working on. So it did feel, I think, it made it feel like a more immediate thing than turning in homework and then waiting a while to see what feedback you're going to get. But I think the biggest deal was there was this step from doing work in their notebook to going to the WikiLog. And in that step, they had to reflect on what they did in their notebook. And I actually had students comment to me that that made a big difference. I suddenly had to process all this work they had done and say, okay, what's the important thing to communicate in the WikiLog? And another thing was, it's kind of a pain to tech things up. So a lot of times they had to translate equations into a sentence or two. It's easier to explain the computation in a sentence or two than to tech it up. But thinking about explaining the computation in a sentence or two is a big deal. So I think this reflection and the necessity of coming up with observations and questions was really, really key to it. Okay, so that's all I have to say. Thank you for coming. Any questions?
A two-part question, if you would be so kind. Was it graded, their contributions to the WikiLog?
Yeah, but it was like a check minus, check plus, sometimes check plus plus. But it was really on their effort. It wasn't on correctness.
And how did the students react to the requirements that they had to fill out, somewhat like an online journal?
It didn't bother. They're already, this is a sequence of courses, so I get them for 3 quarters, and they'd already been doing it in their notebook. When I said you got to put it online, it wasn't bad. They weren't too upset, but they were already also building a wiki. So again, and I did emphasize you don't have to typeset long computations. And in the beginning, some of them would do that, and I'd say, I don't need the whole solution, just the answer. I believe you did the work, that kind of thing.
Hi, how much of a burden was it on you workload-wise? Like, how long would it take you per class to go over these things before class?
I think, initially I started trying to give them their check score while I was preparing for class, but I threw that out the window. It took me less time to prepare for class, that piece of it, because I would just look at their WikiLog, and as I'm looking at their WikiLog, I say, so-and-so should work on this problem, so-and-so should work on this problem. That became very efficient. But I did have to go back after class. It might take 30, 45 minutes to go back and give them their check score. And I didn't respond to every comment. So there wasn't an expectation that I was going to be responding to everything, because that would have made it take a long time. So a lot of them would just get check plus, good work. Yeah.
Would each class have its separate WikiLog page, or how does that work? I'm not familiar with that.
The WikiLog?
Yes.
I could make it a personal wiki where each student could only access their WikiLog, and I could see it because I was the instructor. But we also had a class wiki, which was a totally separate assignment, which each student in the class could see, but no one else could see.
How did you determine which problems students would work on? Did they just have a choice of anything, or did you have a couple problems that everybody worked on? Or
I assigned pre-work before class each time, and so it would be, so I would sit back and think, and I'd have to assign at the end of the previous class, because then I'd decide, where are we going to go next. So I would try to make it enough work where we would get to the interesting thing I wanted to get to next class.
so, as a follow-up, was the wiki? Did you have the questions written into the wiki? Was this like a worksheet they were filling out, or was this you had the problem assignment somewhere else and they?
They had notes for the class, and I would just say, do problem 8.4, 8.5, 8.7.
Okay.
And then they would go through and do that. So and the fact that it was a standing assignment made it easy to regulate, because I just did the problem numbers and posted that. That's it.
All right, let's thank our speaker.